Let's introduce our keynote speaker for today. Today we have Vic Vedantham with us from Autodesk. He's part of the Fusion 360 leadership team and responsible for business and go-to-market strategy for the Fusion 360 platform and digital manufacturing offerings. And I know he helps customers innovate and gain a competitive edge and advanced manufacturing. So Vic, welcome, and thank you very much for being here today.
Thank you, Rob. Appreciate it. All right. Should I take things off from here?
Yes, please.
Wonderful. All right. Let me share my screen. All right. Can you confirm you see my screen?
Yes.
All righty. Wonderful. Well, I thought I'd begin with our standard safe harbor statement, as I may make some forward-looking statements during this presentation. So thanks for bearing with this. First off, thank you, Mark, Greg, Rob, and others for including us as part of this discussion. I'm honored to be out here to talk to all of you about a very interesting topic, actually, that's near and dear to a lot of us, which is really where is design and manufacturing headed in the future. So my name is Vic Vedantham. As Rob mentioned, I'm the Director for Business Strategy for Fusion 360, which is really our cloud-based platform for design and manufacturing out here at Autodesk. Before as I was working on the content for this presentation, I was checking out your website for CITEA. And it's very inspiring to see that, there is a consortium of teachers actually providing that support structure to help other teachers in the process. And we are truly honored to be part of this community and help you along in this journey. To me, particularly in these times, this talks about resilience. How do we, as human beings, support each other in times of need? And this is a classic example. In fact, today, what I would like to talk to you really about is not just the shaping of the future of design and manufacturing to address the emerging needs of the manufacturing sector, but also how about we build resilience in our systems moving forward. We are living in these unprecedented times. There's a lot of change, there's a lot of disruption, there's a lot of challenges ahead of us. But the way that we see it is that this is an opportunity for new perspectives and new emerging opportunities in the industry as well. Now, for those of you that are familiar with Autodesk, you probably have heard us or you're aware of our mission, right? Which is really to make tools that help people make a better world. Now, we help our customers design and make pretty much anything that you see out there, whether it's a skyscraper or if it's a car or different, infrastructure and bridges, all the way up to even blockbuster movies. Chances are, you've either touched or experienced or really seen our technology being used to define everything around us. Now, the reality today is that there's over 7.5 billion people that's out here in this planet. The middle class, if you look at the middle class, it's actually growing at a very, very fast pace. It's fastest in any time in the history of this planet. By the year 2050, the expectation is that there will be about 10 billion people out in this planet. And 2/3 of this population are going to be living in major cities, and they're going to have a lot of emerging needs. As you see this big explosion happening in population, there is going to be a greater demand for almost everything that's out there, whether it's food, water, housing, whether it's products, transportation needs, you name it, there is going to be a need for more and more resources. So in other words, more is pretty much inevitable for us in our future. But more demand doesn't necessarily mean there's more jobs or there is more food. The reality is that the scale is not perfectly linear indefinitely. In fact, as we start making more and more things for more people, we increase the potential for actually negative impact. The more we make, the fewer resources that we have left, which means there's lesser natural resources, lesser skilled labor to go around. So for example, in the manufacturing and construction space, we already face a lot of gap and skilled labor shortages. So less is going to become a reality that we must all face and we must all get comfortable with. So the question that we need to really answer is, how do we start and making and building all that humanity is going to need over the next 2, 3, 4 decades, while balancing that with the impact to the planet, right? Less depletion of natural resources, less wastage, less emissions, and so on and so forth. Now, we just know for a fact that we just cannot continue at the same pace as today. We need to produce more products and more buildings and serve a growing population, but we need to balance it out with the amount of natural resources. So there's a capacity issue, and we must rethink the way that products are being made. That's a massive challenge for the emerging professionals of tomorrow. But the reality is that this is actually the biggest design and manufacturing opportunity that we have ever had. So let me explain that by observing some macro trends that's happening around us. Now, before the disruption that was caused by COVID-19, we already were seeing some interesting trends in the industry around us, right? We've been seeing that products are getting increasingly smarter and sophisticated. There are many processes around us that are getting digitized. And we're also seeing that the production economy is also changing and going through different shifts. I'll give you a few more details on this front. Think about products around us, right? Almost any product that you can touch and interact with today integrates mechanical, electrical, and software design. All three disciplines are coming together. The things that we make today all have sensors. They all have software. It's actually a pretty smart marketing technique to talk about how your product can interact with you and give you insights. And things get more and more connected as well in this process. The experience of this convergence of disciplines that's happening is really shaping what we and the upcoming generations will experience on a day-to-day basis. Now, think about the processes associated with it. The way that we work and the processes that are involved in this process or in making these products are also transforming. As we move from this analog world to more of a digitized world, the reality is we're not constrained anymore by the traditional processes of manufacturing. The flexibility that we have in manufacturing processes, the emerging production methods, new materials, hybrid technologies like additive followed by subtractive, and the advancements happening in robotics, AI, and AR/VR are really going to change the way that products are made in the future. Digitization is going to give us the opportunity to make products that have increased value, that perform better, they're more resilient, they're highly customized as well as configured, and ultimately that are more sustainable as well. Now, I'll give you a couple of data points on this as well. By the year 2021, it is expected that there's going to be nearly 27 billion networked devices out there in the market. That's a greenfield explosion that's happening that delivers a lot of insights to people so that they are more productive. Now, simultaneously, there's a brownfield explosion happening. When you think about these machines that we have come to love and work with over the past few decades, these machines have largely been offline, and the process of actually manufacturing has been a very disconnected ecosystem. But as this gets more and more connected in this digital world, the line of sight in terms of production economics is going to change the game and offer new realms of transparency. As the products are getting smarter and as the processes get digitized, what's also happening is that the supply chains start getting reorganized. Even before the COVID crisis impacted us, the impact of technology and digitization has had a significant impact estimate on trade. It's estimated that as the digital platforms come to being, there's going to be a significant addition in how trade and transactions happen between global economies, as well as the advancements in robotics. By the year 2030 is expected to create a shift of roughly $1.5 trillion in the market. Now, it's important to take this into consideration, particularly at a time like this, when the supply chains are being disrupted because of global economic crises. Gone are the days when we think about the traditional assembly line. At that time, we had specialized workflows, we had serial processes, we required human interaction at nearly every stage of the process. Manufacturing is going to start looking more and more like the image that you see on the right side here, where contract shops will receive a wide variety of jobs. They will work on it on a digital mechanism. It will perhaps be ordered directly from a website. The processes will be flexible, customizable, non-serial, and they will probably require minimal human interaction as it gets progressively made. Now, as we put all of these things together, you've got to think what the future of design and manufacturing is. We've been talking about future of making with our customers for a while now and preparing them for a future that's going to look very different from today. But few of us really predicted a global economy that would be shut down by this pandemic. The once reliable supply chain are now unable to fill orders, forcing companies to think about finding new sources for parts and production. Processes that rely on the manual work and the interactions that we have experienced are getting increasingly cumbersome to deal with. And non-existent collaboration strategies has really crippled the manufacturing economy quite a bit. The year 2020 has really been a wake-up call for us all. At this time and age, we've been hard at work thinking about what the manufacturing economy really needs. Autodesk's direct response to COVID-19 has leveraged the collective skills, resources, and knowledges of what we have as an organization to start assisting customers as well as the people around us in dealing with this crisis. And we have really looked at 3 time frames to help deliver this impact. The first one is response. How can we help the world deal with these immediate needs in healthcare, in well-being, as well as the economic disruption happening around us? Second, how do we start that road to recovery? How can we help our society contend and deal with this so that we can return back to some state of normalcy without compromising health in the process? But the third thing becomes the most important, which is resilience. How might we design and build future systems that really makes us shockproof, right? Makes us more resilient to the effects of something like this, like a pandemic. While the first two are sort of more immediate pressing needs that we are reacting to, building resilience is very critical and requires a long-term strategy. So today, I would like to focus my talk specifically on building resiliency in product development. Now let's talk about product development specifically. The product development process, if you go from start to finish, from concept to the production stage, is relentlessly linear. It's a complex mechanism, and it's filled with numerous points of friction and inefficiencies. Now, in the simplest sense, most products begin with a concept phase. They're followed by detailed work around engineering, perhaps some validation, and then eventually it goes through a manufacturing preparation phase as it makes its way to the shop floor to be produced. Engineering management and these organizations have to navigate through this complex minefield in order to take a product to market in the shortest time feasible. And this is the underlying denominator that makes or breaks a manufacturing organization. Now, that is not all that they have to deal with. It's not just the process complexity. They have to do this as a team. No product is designed and produced by an individual. I want you to think about the individuals, the departments, the organizations that all have to come together in this journey as the part moves from a concept all the way up to the production floor. So the question that we as an organization have asked ourselves is, what has the technology market done over the past years to address the needs of these professionals? What's interesting is that at each stage of these 4 processes, there is a handoff point. And the disconnect that's happening right now in each of these stages causes a lot of rework that happens and reformatting and often loss of data in the process. Now, these are 3 critical traits that sort of inhibit productivity and innovation in the market today. This is the traditional process. It's not flexible, it's slow. Trying to change something downstream becomes really painful because everything is cost prohibitive. And so as we think about this framework, let's keep revisiting this graph in this discussion for me to tell you how, as we define the future of design and manufacturing, we can impact this curve and positively drive up productivity as well as inspire innovation. So the questions that we need to ask ourselves is, what if technology could break these pervasive barriers of data, experience, and collaboration? What if technology can develop that needed resilience for stability? What if technology can provide that leap in innovation and productivity while mitigating the risk involved? These are the things that we have been exploring as an organization to test the boundaries of these possibilities. And it's particularly relevant right now with the crisis going on, because we believe that the working professionals of tomorrow will rely even more on platforms like these to address such questions. So how do we solve this problem? The first thing is that we need to think about the data that gets created in a product development process. Data is critical regardless of where you are, whether you're building a concept or whether you are engineering it or whether you're sending it off to the shop floor as a drawing or you're worrying about what happens at the machine. Data is everything. So the process really starts with putting data at the center and connecting every stakeholder at every stage of the process to that data. In fact, that's one of our core missions. We are connecting these workflows from concept, mechanical engineering, electronics design, simulation, and ultimately manufacturing into that single data repository so that the entire team can start collaborating seamlessly around the data. Now, as a technology company, we believe that as we start breaking down these points of breakdown and we connect everything through a digital thread, the experience really becomes more homogenized. So let me give you a couple of illustrations of how this will look like. Now, if you take, for example, a company that's designing a product, and we spoke about smart products before, it is important that you think about the electronics working concurrently with the mechanical engineering aspects. So in this example, you see that the user is working inside a single platform and starting to describe the schematics, the PC board layout, and then ultimately creating a 3D representation of the same. The nice thing is that one single homogenized experience, the user is able to take all of that data, do a full-on schematic layout, and take it all the way down to manufacturing. Now, as you watch this video, you not only see that kind of activity going on, but you also have the ability to understand the performance aspects. So you can actually do a circuit board simulation and understand the thermal properties involved. But that's not where the buck stops. As design changes happen, it is important that everything updates real time. So in this example, you actually see the PC board layout reacting to how the constraints on the manufacturing space or the structural space exist simultaneously. Now, once you have the design ready, the next phase of it is how do you manufacture it? On that same platform, we have also enabled the ability for you to do all kinds of manufacturing preparation as well. From standard, milling operations all the way up to additive processes, we are able to handle all of these workflows so that the user experiences the right aspects of manufacturing within the context of the design process. So as we looked at this example, you can see the user not just doing milling operations and understanding what happens in the machine, but also able to do additive workflows and then finally finish it off with subtractive machining techniques so that they can either decide to go to a CNC mill or they can decide that going additive is perhaps the right route with a little bit of subtractive finishing involved at the end. A good example of this is a company called Life Fuels. Life Fuels make these bottles that actually produce vitamin shots into water, thereby enriching the experience of actually drinking water even. And you'd think that something as benign as a bottle of water is just a simple design. But the reality is when you embed electronics into it, the problem becomes much more inherently complex. So you see this engineering team working alongside the electrical engineers to actually concurrently design the schematics involved and being able to collaborate seamlessly with their mechanical engineers so that they can actually produce the right design configurations that work. So this is a great example of how products get smarter and how it's important to take into account the electronics, the mechanics, and the production all together simultaneously. Now, if you looked at it from this curve perspective, we just spoke about a single platform delivering that end-to-end experience, and you can start seeing how keeping that data as a centralized piece of information, we start eliminating those disconnected handoff points between departments and reduce the need for data recreation at every stage of the process. The net result is faster design iterations for superior outcomes, as well as significant time savings in the process. Now, once the data and the workflows are connected in the process, we can move to the next stage, which is how do we automate repetitive tasks in the functional silos. Now, we're bridging the gap between the top floor and the shop floor in this space by connecting engineering directly to manufacturing and using tools like artificial intelligence and machine learning to put this on steroids. Now, we use a term called generative design in the industry, which specifically talks about how intelligence can be brought into the ecosystem. And teams can explore multiple scenarios or multiple design configurations. Years of research and exploration that we have put into the space actually take advantage of technologies like cloud compute, as well as self-driving algorithms that help simultaneously explore multiple concepts and produce results that perhaps an engineer or even an engineering team may not have thought about for a design problem. Now we can then take all of that into the shop floor to enable powerful new production techniques and manufacturing technologies to supercharge that entire process of design to manufacturing. Now I'll speak a little bit about generative design. At its heart, this visual shows what generative design truly is. It is the process of creative exploration of designs at the concept phase. It's extensive design exploration so that the user can look at multiple potential viable solutions to a design problem very early in the design process, and then make a very, very strong decision on what design they ultimately want to promote down to the manufacturing phase. The interesting thing about generative design as a philosophy, and the reason why it is starting to become the new buzzword in the industry, is because it allows the simultaneous exploration of not just the spatial orientation of the parts, but also does it with a manufacturing aware as well as a performance aware state. Ultimately, we have also stitched in the economics of production into it so that the user, right at the beginning, is aware of all three principles while they think about the right design to move forward. This really empowers the engineer to select the best design option that is already validated and it's really ready for production. Now let's take an example in this case. General Motors is a classic example. Automation through generative design is actually helping General Motors make parts that are really not just lightweight, but also more fuel efficient. So if you look at this seat bracket example on the left side, it is really 8 different parts that have been manufactured using various processes that have been put together. What General Motors was able to do is take generative design and put it into effect here to try to consolidate all of this into a single design that not only performs better, but is actually lightweight as well. So what you see on the right now is really a single part that can actually be 3D printed rather than assembled from 8 separate components. And it happens to be 20% lighter and 40% better performing. Now, this is just one single location in that car seat assembly, if you think about it. A typical vehicle has tens of thousands of parts. So you can imagine what the engineers can potentially do when they harness the power of automation and technologies like these to empower engineering teams to be more successful in designing really, really optimal solutions. Now, that was an example of General Motors, right? While they were designing a bracket that was ready for 3D metal printing, generative design is not just an additive manufacturing solution. It is manufacturing aware in its truest sense, which means it gives designers viable options for exploring multiple manufacturing methods, whether it's 2.5, 3, 5-axis milling processes, whether it's casting, as well as additive included. The nice thing is generative design is also cost aware, which means that you can actually understand the impact of the production costs early in the design process and take that into account when making design decisions or design choices. This example that you see here is actually a tri-clamp on the front of a motorcycle. And you can see the user actually exploring various design options, this time constrained by the traditional milling operations, whether it's a 3-axis operation or a 2.5-axis or even an additive process. And that side-by-side comparison of all of these manufacturing methods really helps that engineering team think out of the box and explore what is the best solution for the problem. Now, while generative design as a philosophy is becoming more and more common at automotive OEMs, we're also starting to see adoption from other industries. Consumer products and building product companies like Festool, industrial equipment manufacturers like a Claudius Peters, who have been making parts for the past 100, 150 years, and it's a traditional steel manufacturing industry. They're also starting to adopt these technologies to take advantage of the power of driving innovation within their company. Now, so what does this do in terms of the graph that we were exploring? While connecting workflows will lead to these incremental improvements we spoke about, when you start sprinkling in artificial intelligence, self-driving algorithms, machine learning, and the power of cloud-based compute, we start seeing exponential gain, not just in terms of the outcomes that we generate and the superiority and quality of it, but also the time savings aspect of it. And this wheel really represents how we can connect the entire experience from concept through engineering, ultimately to manufacturing in one single experience. Now, the final step in this journey is really digitizing this entire process. We spoke about the convergence of technologies. We spoke about putting it on turbo boost with automation and AI. Now, how do we digitize this entire process? Well, digitization is important because it connects teams within an organization across engineering, production, procurement, quality, and operation. But that connection just doesn't stay within your own walls. By leveraging collaboration and integrated data, we can connect these organizations all the way through to the supply chain. And that way, everyone stays connected 24/7, even during times like these, where you have a crisis going on. And when the networked organization is connected to that digital thread, that data that they can harness offers actionable insights that can be used for better decision making. Let me illustrate that with this example. This image really represents what happens within a manufacturing organization, not just within their own walls, but also as they interact with their supply chain as well as their customers. It's estimated that roughly 30% of an engineer's time is just wasted on tedious, non-productive tasks, like chasing down the right version of a file or trying to figure out what the current latest edition is and how to handle the management of that file as it goes from one location to another. This is a huge impact on productivity. And frankly, if you talk to engineering leadership or manufacturing leadership within these organizations, they really struggle with this pain point. What we at Autodesk are aspiring to do is to solve this problem. Now more than ever, we all need to work together in networking this entire manufacturing ecosystem. This is one of the core philosophies of what data can really drive forward. By digitizing this entire experience, we can connect departments within an organization, and we can connect organizations across the supply chain, and most importantly, reach out to customers as well. This digital thread will completely change how design and manufacturing work, not as a sequence, but really as parallelized processes. Now, to realize this vision, as you can imagine, cloud has become a requirement. It is a tool in the process. It is not necessarily a solution in and of itself, as much as a means to get to that end. It is really no longer an option, but really an absolute necessity to keep teams connected and to keep companies running. At Autodesk, we are not new to the cloud. We've been leading in cloud collaboration technology for more than a decade. We've been looking at how we can harness the power of the cloud and drive such intelligent operations to create that digitized experience. And we have started building that foundation for a manufacturing ecosystem using what we call as a Forge platform. Now, I do want to call out that as we think about this, we're not talking about single products. We talk about bringing multiple designs together or disciplines together. At Autodesk, we bring all these disciplines together in a single cloud-connected platform called Fusion 360. Fusion 360 is not just CAD or CAM or simulation or documentation or rendering or electronics. It's really all of these things that are working in concert in that common platform so that it can drive that end-to-end value for every persona at every stage of the design process. Now, as we think about what technology can really do to start changing the game in design and manufacturing, it's also important to recognize the skills gap that's happening. The global skills gap today represents a really looming crisis across all industries that Autodesk serves. In fact, by the year 2020, which is really, by the end of this calendar year, we think that there's going to be 95 million workers that will lack the skills needed from, out there for employment purposes. Our customers face a retiring workforce. There are productivity issues that they have to deal with. There are ever emerging technologies. And so we can imagine over the next 10 years, as the world of AI and AR, VR and IoT starts taking shape, it's important that people can account for an ever-changing future of work. There's also a stiff competition for qualified talent. And it's estimated that there's roughly about 2.4 million open positions that may lie vacant because of a skills shortage in the manufacturing sector in the next 8 years. But the reality is that the next generation presents that opportunity to address this gap. And that's why organizations like yourselves become a critical part in this ecosystem. If you look at Generation Z, this is roughly people born after 1995. They're a global population of roughly 2.5 billion emerging future professionals, and they represent a larger cohort than even the millennial group. This is really the first truly digital native generation. These are the people that understand what technology truly means. They are tech savvy, they are highly curious, and they are resourceful. And we see the impact of all of that around us. I've got 2 kids of my own, and they are in love with technology. That's what they live and breathe day in and day out. The world around them is changing rapidly, and it's important that they figure out how they can harness this technology for the future. And that's why, for us as an organization, students represent the largest single customer cohort. We have more than 8 million registered users in the Autodesk education community. There's more than 800,000 schools globally that are integrating technologies like this into their curriculum. Autodesk, as an organization, is really committed to offering students, educators like yourselves, and academic institutions worldwide open access to our broad portfolio of design and manufacturing software, so they can learn the same tools that professionals out there use every day for free. It is important that we educate these students about how the product development process can become faster, how they can innovate faster, and how they can actually realize products that get smarter by the day. From design to manufacturing, we serve the entire ecosystem from K through 12 to post-secondary, and we offer an extensive pathway for lifelong learning and job readiness for the community. Now, but the story does not just talk about what we are doing today. It is also important for us to reflect on what is to come. Now, we saw some effects of some of the future-looking technologies like AI and ML come into the equation already. But I'll tell you this is just the beginning. We are just about starting to harness what truly artificial intelligence and machine learning can mean in the process. Now, what if AI and automation can do more than just make better parts and products? What if it could go back and start changing how the work experience really is? What if it could create more meaningful work experiences and better the working conditions around? What if it could help build the factories of the future? These are the questions that we've been starting to tackle as part of our future research efforts. And we interact often with the professional organizations to understand whether it truly makes a significant impact. One company that we've been working with and that has been thinking about this is Airbus. So what Airbus did is they identified that it's not just about designing parts and products. There are several higher order goals that they want to start optimizing for, whether they are social goals, like a customer experience or work conditions, whether they are environmental friendly goals like sustainability, the impact on wastage and material scrap, and so on and so forth, whether it's financial goals like flexibility, the ability to actually design to cost, the creation of the factory itself, or whether it's operational goals such as the flow of materials and resources and creating efficiencies in the process. These are all the higher level constructs that happen in a manufacturing organization. Airbus really wants to aspire to build the best conditions possible for its workers. So what they wanted in this case was a building that would really hit those highest standards for sustainability. And that was one experiment that we've been partnering with them on. But not just sustainable goals were important to them. They also wanted to make sure that it continues to stay affordable simultaneously. And what was absolutely critical to Airbus in this journey was the way the factory operated in and of itself. So we helped Airbus look at different flows of people and parts between these 3 key areas. We've developed new functionality in generative design that enabled it to clamp these values around their existing standards, which are incredibly exacting. From many options that were explored, Airbus chose several designs that looked promising, and the team narrowed it down to these 2 options that you see on the screen. Both these options, actually, as you see on the spider graphs on the bottom, they have better flow scores than the existing standards that they have. So really, either of these factory workflows will function more efficiently for them. Now, whichever direction they take, Airbus is confident that the aircraft will be made more quickly, and the logistics and the flows are more efficient and sustainable, and the workers will be more effective in their jobs. You can see how a tool like artificial intelligence is helping Airbus to create that better condition to help both the business and the workers prosper in the journey. So I'm going to leave you with a couple of parting thoughts here. I began this presentation by talking about our opportunity to do better. To do better as manufacturers, to do better as a society, we will need to learn how to do more with less. This is where education starts playing a very critical role in enabling these emerging professionals to be successful by taking on technologies like these and starting to inculcate that in their day-to-day processes. If we want to be successful in this endeavor, it is extremely critical for us to start thinking about tools like artificial intelligence and automation and machine learning, to start using these technologies responsibly, and to make this technology affordable, accessible, and easily usable to everybody. Now more than ever, this is not just an opportunity anymore. We literally have an obligation to do better with the crisis that's emerged around us. At Autodesk, we believe the better starts here. We want to ensure that everyone can join this journey. With that, thank you.
Thank you, Vic. I think we have time for a few questions. What questions do any of you have about the topic that Vic's been discussing?
Hey, Vic, I'd just like to say that I'd like to thank you and Autodesk for coming and being our keynote speaker today. And, you know, you hear the phrase, think outside the box and look into the future. You made some great points and gave me some really good things to think about. Thanks.
Absolutely, Mark. Thank you. Thanks for the opportunity. And we're more than happy to continue to collaborate. You know, like I mentioned, we have a huge focus on education. We want to make sure that you have all the tools that, as educators, you can continue to help the future professionals succeed. So this is an important mission for all of us in this journey.
Hello, Vic. I'm Martin. I work with Rob in teaching our metal casting class and stuff. And I'm the old retired guy, and Rob's the young guy. He's really led the way to digitize our class. So when this whole teach from home hit us, we were already ready because of what Rob has done. But what I get out of a presentation like yours is that, well, we teach a freshman level class on metal casting and rapid prototyping, but we really need to keep going and have them work in the teams and have them start collaborating at the freshman level. What I love about these conferences, even though I'm old and I just want to go walk the dogs, I get inspired to start over again. So thank you again for being here and having that, and we'll be in touch, and maybe someday we can meet up at Carl's shop and we can all get in there and see what craziness he's currently doing.
Absolutely, absolutely. And that's, you know, it's heartening to hear that we all believe in the same mission, right? It's not just about digitizing, but it's about driving that collaboration. We just cannot function as independent individuals in the society. And I think that's an important factor that everyone needs to recognize and start building inherently within the next generation. So this is a critical mission. So thank you for the work that you're doing. And you know, we're keen to continue to participate and figure out what we can do to help that journey.
You know, our model here at Cal Poly is learn by doing with the hands-on. And it's always been a pleasure to get a student who's never seen liquid metal before actually design a mold, make it, cast it, clean it up, and it's great, and we're missing that. But when we went online, Rob's led the way to doing the breakout groups and having the students interact. And so I'm wondering if part of our model at Poly should maybe change from or increase from learn by doing to learn by teaming and have that collaboration. So the future looks exciting.
All right, if there's
Hey, Martin.
questions. Oh, please go for
Hey, Martin, maybe you can pick up on a CB and say our team can do.
Okay. but we want to have teams collaborate with teams too. So
Well, just add an S.
there you go. There you go.
Well, Vic, you gave us a lot of exciting things to think about, and I'd like to incorporate some of those to inspire these young students so they can stay motivated to get through the basics. And, but you showed us a lot of things that really look exciting about the future. And then if we can turn those numbers in terms of the shortages of skilled people that we see in the future into the opportunity that it really is for those students, I hope to somehow get my mind around how to break that down into something that's motivating to the students and gets them excited. So thank you for sharing all of this with us.
Very good. No, thank you, Rob. It's my pleasure.
I look forward to collaborating again in the future.
All right, wonderful. Thanks, everyone.